Okay, we're going to be looking at section 2.1, which is organizing qualitative data. And remember, these are data sets that we can put into categories and that numerically they don't make sense. The differences in values don't make sense. Qualitative are, built in there you can see almost the word qualities. They can be broken down into categories. So for this lesson, we're going to organize qualitative data into tables. We're going to construct bar graphs and pie charts. Now, you're not going to need to test your artistic ability. We are going to use a program called StatCrunch to create these bar graphs and these pie charts to make them look really nice and presentable for us. So the first thing we're going to do is we're going to look at organizing qualitative data into tables. Okay, so again, as I mentioned before, just remember that qualitative or categorical data, those provide measures that categorize or classify an individual. When we've got the raw data collected, first, oftentimes we need to determine the number of individuals that fall into each category. So we've got to break this down. So we're going to create what's called a frequency distribution. Okay, and a frequency distribution simply lists each category of data and the number of occurrences for each category of that data. So, like in this first one, we have the response to a survey and the number of times that we got that response, or the frequency. So, asking people about cars. And so in this first one, I do not drive a car. 249 people said they do not drive a car. I think this one was in response to wearing a seatbelt, if I remember, or something like that. But anyway, of the respondents, 249 say, well, I don't drive a car. Those that said never was 118. Those that said rarely was 249, and so on and so forth. And this is what we call a frequency distribution. We can get a quick glance at how people responded, and again, this is qualitative, so we're able to organize our data from a whole bunch of responses. Instead of just saying, I do not drive a car, I do not drive a car, and have that listed out 249 times, we just create a nice little table here that goes through and cleans it up for us. And then in the frequency column, when you total up, when you add all of those frequencies together, okay, that's the total number of respondents or people surveyed or data points. Okay, so when you take 249 plus 118 plus 249 plus 345 plus 716 plus 3093, that is the total number of respondents. And if you add that up, that's 4,770 people responded to this survey. Okay, that's called the frequency. It just counts them up. Now the next one is the relative frequency. And the relative frequency is the actual proportion or percentage of observations within a category. And we are going to use this very often in this class, but the relative frequency is found simply by taking the frequency in that category and dividing it by the sum of all the frequencies. And so what I'm going to do is I'm just going to expand this. Okay, and this is going to be the relative frequencies. So for the relative frequencies, what you're going to do is you would take, in this case, there were 249 who said I do not drive a car, and you were going to divide that by the 4,077, the total number when you add up all of those frequencies. Okay, and that gives me 0.052. And that is the relative frequency, that 0.052. Then I'll go down to the next one. I'll take 118 divided by 4,077, and that is, rounded to 3 decimal places, 0.025. And then again, 249 divided by 4,077, That should be the same thing as above, 0.052. So you'd keep doing that down and down and down. And so then I'm going to get a 0.072, 0.150, and a 0.648. And you would expect the bottom one to be the largest decimal, because, or percentage written as a decimal, because that's where the most respondents fell. And when you total up your relative frequencies, these should always add up to 1. So the sum should be equal to 1, or approximately 1. If I'm rounding some decimals here, so I might be a little off because of my rounding, but it should be, if I were to add those fractions, it definitely should add up to 1, meaning 100%. So like when you see the 0.052, for example, that's 5.2%. Okay, but again, when we do calculations in math, the decimal form is what we're going to be using instead of the percentage. So our relative frequencies will be written as decimals unless we are told otherwise. Okay, now a bar graph hopefully is not anything new to you, okay, but it is constructed by labeling each category of data on either a horizontal or a vertical axis. Just depends on how it's best going to fit, how you want to display, those kinds of things. And then rectangles of equal width are drawn for each category. So that's going to be these rectangles right here. The widths are all equal. And the height represents the frequency or the relative frequency. It just depends on what you're looking for. So in this graph, for example, this is the frequency in thousands. And so when we read this question here, so the U.S. Census Bureau uses money income thresholds to define poverty. For example, in 2013, the poverty threshold for a family of 4 with 2 children was 23,264. Now the bar graph represents the number of people living in poverty in the United States in 2013 by ethnicity. Now remember, these numbers are in the thousands. And sorry, I had to fix this one because it came out blurry. So like, for example, the first question down here, part A, says how many whites were living in poverty in 2013. So we look for whites, and that number is 29,936. But again, that's 29,936,000. So that number actually represents 29,936,000 because they are in thousands. Okay. The next one, part B, so I'm going to do part B up here, says of the impoverished, what percentage were Hispanic? So the Hispanic population is right here. So I'm going to find their relative frequency. So I'm going to take 12,745. I'm going to divide it by the total frequency, which is 29,936 plus, so that was for the whites, plus black, which was 11,041, plus you do need to throw in the Hispanic in there because they are part of the sum total, even though we're finding their relative frequency. So we've got to take, we're taking the again, we're taking the number of Hispanics, which was 12,745, and divide it by the sum. So add up all of these numbers, and that will be our relative frequency. So when I add those up and then divide, I get about 0.229 or 22.9%, because the question is asking what percent were Hispanic. Okay, now on this one here, it says, how might this graph be misleading? Okay, now one thing we don't know in here is we don't know the real population values for each ethnicity. And so rather than looking at here we're looking at the frequency, it would probably be better to look at the relative frequency. And so, for part C, just say something like, we do not know the real population values for each ethnicity comparing the relative frequencies would be better if we knew the relative frequency of whites, blacks, Hispanics, and Asians within this country. Or in this case, it's the United States because it's based off of the U.S. Census Bureau. Okay, the next little piece here is looking at pie charts. Okay, again, pie charts, hopefully it's not anything new to you. I don't expect you to draw perfect circles and break everything down, perfect angles and those kinds of things. We are going to be using technology to create pie charts, but just know that pie charts are used when we are trying to represent categorical data or qualitative data. So each little sector represents a category of data, and the area of each sector is proportional to the frequency. So the larger the area, the larger the expected frequency. So in here, the biggest area for education attainment is high school diploma, so we'd expect that chunk of the pie to be biggest. Again, hopefully this is nothing new, but it's just another way that we represent our qualitative data. Okay. Let's see. I'm just looking to see what we have. Almost up against the clock for the first part here. So let's go ahead. I'll pause it here, and we'll jump to part 2 to go over a couple of questions.